Hello, and we're going to continue our videos on section 4.4, working with rational functions. And in this video, we're going to look at transformations. We're going to look at the three different types of transformations. We've talked about this earlier, but the three different types of transformations here are our vertical stretches. So first, vertical stretch and shrink. We have a horizontal shift and a vertical shift. Now we've looked at these in other functions, but we're going to look at these specifically in a rational function here. So here's my basic rational function here, 1 over x. We're going to look at how we change this to do these three types of things in the actual function. So here's my rational function. I have the values here. We have our asymptotes that we had before, and we have our information from the previous video. Now what we're going to do is we're going to use this information to help us transform this graph. F of x is equal to 2 over x plus 3. So we're looking at 1 over x and seeing how it's changed. So in this case, we're going to say our first transformation is 2 over x, which is going to be a vertical stretch of a factor of 2, because we got from 1 to 2 here. So that's our first transformation that happens to this graph. So basically that's going to make all of these values double. So instead of having 1/3 would be 2/3, and 1/2 would be 1. So each value here would double on this graph. So my first transformation of just going to 2 over x here, if I were graphing 2 over x, then at 1, we're going to be at 2. At 2, we're going to be at 1. At 3, we're going to be 2/3. At 4, we would be 1/2. At 1/2, we would be 4. Okay, and then so our graph kind of looks like this for just 2 over x. Oops, missed a little bit. This would be 2 over x here. And down here we'd have the similar values. -2 would be -1. -1 would be positive, or -2 here. So we'd have this, and then 1/2 would be -4. We'd have the same thing going on here. 2/3, 1/2. And it goes and approaches the axis as an asymptote. So this would be our 2 over x. Now, then what we do is we're going to, for our next shift, we would do 2 over x plus 3. So this is within the function. We're adding 3 within the function, and if we did that, what happens is that we shift right or left. Anytime we add within the function, that means within the denominator here in this function, because that's where our function is. This is going to be a shift left 3 units. So that means this graph moves over 3 this way. 1, 2, 3. Shifted over. It's shifted over. Our asymptote here at 0 would be shifted over to 3. Oops, I'm going the wrong way here. So now I shifted left, but I moved right. So we want to shift left 3 units. That's what I said. So 1, 2, 3. So this is going to go right here. 1, 2, 3. 1, 2, 3 goes right here. 1, 2, 3 goes right here. Then down here is 1/2. This one's going to be 4. So what's going to happen is this asymptote that was x equals 0 is now going to be x equals -3. So my asymptote changes to here at x equals -3. So our graph is going to come down just like it did before. And it's going to have a horizontal asymptote at 0 still. Now this one's going to move back 3 units as well. So this goes 3 units back. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So this one's going to come through here like this. And that would be our final transformation. So this red graph that I've drawn here is going to be f of x is equal to 2 over x plus 3. It has two transformations. It has a vertical stretch of 2 because of the 2 in the numerator, because it's 2 times 1 over x. And then it shifts left 3 units because of the plus 3 inside the function. So the vertical asymptote, or the asymptote here, changes, but the horizontal one stays the same. And we'll talk about that in the next video. So my next example is going to be dealing with this graph right here, 1 over x squared. And here's the information we had about that. We just square everything and take the reciprocal. Our end behavior is described. So does the end behavior, let's go back to this one. Does the end behavior change here? No. It's still going to 0 both ways. It still goes to, in this case, it does change the behavior about x equals -3. So in this one here, we would say as x goes to 3 on the negative side, that would be f of x goes to -infinity. And if x goes to 3 on the positive side, and then f of x goes to positive infinity. So as we come from the positive side, we're still going to infinity. Negative side, we're coming down to -infinity. So that changes, but the end behavior coming out to infinity doesn't change. All right, now in this example, as I said earlier, we're going to use this to look at our a transformation of this graph, and here's our example. All right, and in this example, we're going to use f of x equals 1 over x minus 3. So you can see the square right here. So that's going to be, that's going to give us our parent function, what we call a parent function, as 1 over x squared. And the previous example was just an x power with the power of 1, so that's what it's going to look like. So let's go back and look at this graph as it transforms. So we have two addition subtractions here. So this is going to transform it right or left. So this one's going to move it right 3 units. And this is going to move it down 4 units because of the -4. So that moves it down, and the other one moves it right because it's inside. Anytime it's inside the function, it's going to move it opposite of what we think here. So let's look at the graph of this. So when we look at the first transformation of moving it right 3 units, that means the horizontal asymptote from our graph was 0. So that means it's going to be 1, 2, 3. So this is going to be where it moves to the right. So as we move to the right, there's our asymptote. So in our first transformation, we're going to, if we just did 1 over x minus 3 squared, we're just going to transform all of these to the right. So we look at these points, and we're going to move 1/9, 3 more to the right. So it's going to be 6 comma 1/9. So 6 comma 1/9. All right, and our next point up here was 2 comma 1/4. So that's going to be add 3 to 2, we get 5 comma 1/4. The next value would be 1 comma 1, so that means we're going to be moving it over 3, so that's 4 comma 1. So it's going to look like that, and it's going to go up towards the asymptote here, just like that, and we have their same similar graph on the other side. It's kind of a mirror image because of the x squared. So we see the mirror of this going on down here as we travel. So this shifts it to the right 3 units. That's what that does. Now, if we're going to do the whole equation, which is going to have the -4, that's going to shift it down 4 units. So it's going to move the horizontal asymptote down 4 units. So now the horizontal asymptote is 0. So we're going to move down 4 to here. So that -4 moves the graph down to this axis. So everything shifts down 4. Shifts down 4, shifts down 4. So our graph looks similar, but it shifted down 4. Now, does this change the domain and range? Yes, it does. Because before our domain and range had some exclusion points. Well, our exclusion points now are shifted. So our domain is going to be all real numbers except 3 instead of all real numbers except 0. And our range is going to be all values greater than -4 instead of values greater than 0. So we've shifted both our horizontal and vertical asymptotes, as that's going to change our range and domain. Okay, so remember, as a summary, we have 3 different shifts here. We have a vertical stretch and shrink, we have a horizontal shift, and we have a vertical shift. Now if we look at the calculator on these, here's my first one plotted. Let's do zoom 4. You can see there's my original graph, and then this one should be shifted, so we can see the shift. It's shifted over to the left, just as I had drawn on this graph. I shifted the red one, so this is the red one right here. So it matches up with what I have. Now I don't see the whole window because my window's cut off here. So that's that example of just graphing that and verifying with your graphing calculator.